It's coming from here. And then he comes up to his next change where it zeroes out, so then you're zeroing out here. And it's all about the change to where you're coming with your graph.
Yeah, like if
Right?
we were...
Is that right?
If
Is that what you're saying, right?
Yes. If we were a car, and this were a velocity graph, right, and this were a acceleration graph, what's happening here is, like she said, here we're going up. We're going up, and we're going up at about the rate of 2 over 1. Because we're just looking at it as an approximation. It's just an approximation. So about 2 over 1. We're keeping it nice numbers, right?
So that's how you got the 2.
So that's how we get that 2.
You're going to go up to where you're getting a 0 again, which is going to come back to 0 on your
And we're
graph.
at the point of -1 on the graph. So that's why it goes at this -1 position on the graph. And then, as it goes up, the major point of change is when it hits 0. When it goes from positive to 0. To negative. Those are major changes that are going on in the function.
So that's how you got the 0, and then you get
And
the
then
negative
that's how we
1.
get the 0.
And then you get the -1 down there with your next
And we
dot.
get the 0 at 1. So that's why we're at 1 here. And then we come negative. We're getting a negative slope of about 1. We're just looking at the negative slope of about 1. So that's why we're coming down to about -1.
And then it's dropping to 0 again.
And then it changes.
Well, changes.
It changes to 0 because, whatever reason, we were saying, hey, if this guy's speeding up, and then when you speed up, what happens when you start to slow down? Right? Your acceleration hits 0. And then you start to negatively accelerate. You start to slow down. That's a negative acceleration. And then what happens when you start to speed up? Well, at some point, when you go from negative to a positive acceleration, you have to what? Hit 0. There has to be a change point of 0. So that's where this is coming in. This 0 is at 2, and this 0
That's where that one's coming in. That's
is
where
at
you put
2.
in
Yeah,
one.
this one, and this one are linked.
So it's like the rise. Then you're going up to the 3, so then you're just going up 3
Then we're
here.
going up, and
That's
we're
where
looking
your
at
dot
3
goes,
right
and then
here.
You're making off to 0 again.
And we're saying, hey, on this point, somewhere on this, we're looking at that slope as being a real tight slope and being, oh, that's it. Rise is 3, run is 1. So we're saying that that's like rise over run. So now we're up to 3. And we come back to 0 and down.
Because your down is when you're dropping.
Yes,
That's
when we
your
get
dropping.
we drop, we stop.
And then you come back to 0 again, which is
That's
here,
it.
and then you got your little rise here, which is here, and goes
That's
down.
it. That's
See,
down.
that's how he's getting his.
Okay? So that, in a nutshell, is how we find the first derivative. Now, to do it really quick, because it's getting late, if you want to go from the first derivative to the second derivative, that's exactly what you do. You look at this function, and you see how it changes, where it's changing.
Just like keep going.
You just keep going.
You can keep going, like we said, and if what happens is you get to the point of x squared, which in this case would be like this, x, which would be like this, which would have some kind of number out in front of it. And that's also what we're going to talk about is these numbers actually do come out in front. So there's a number out here, right, in front of this x, and that's why, and this is still negative, and that's why this is a negative slope, right? But then we take the derivative of a negative slope, and what do we get? We get a 0 in front of the x, right? So, but there's a slope there. So we don't get a 0 in front of the x. We get a number. The number stays out there. The number stays out there. And that's why when we graph this, that's at some point on x. Let's say this number was 5. Then this graph would be at x equals 5. Right? Or I mean y equals, sorry, y equals 5. And that would be like this one, the mouth. And then you take the derivative of that one, and guess what? You lose the 5, and you get a 0. And what happens is y equals 0. Well, what happens when y equals 0? It's just the y-axis, that's all. And you can't get lower than that. You can't get a derivative. You can't graph anything lower than a 0. So it's y-axis is the lowest derivative that you can graph. And then you just, or the highest, I mean, the highest derivative you can graph. And then it derives from all of this. Okay?
I got more understanding of it now than.
A little bit better, yeah.
Yeah, before.
Okay? Cool.
I know.